So this is a quick video about linear equations, chapter 1, section 1 for college algebra. Most of this you should be fairly good at, so I will go through it relatively quickly. These are just going to be a few harder examples than algebra 1. So to start off with, what I would recommend for this first problem is to distribute the 5 and distribute that negative 7. So we would have a 5x minus 5 plus 20 equals x minus 7x minus 7. From here we want to add and subtract to get like terms, on variable terms on one side, constant terms on the other. So I'm going to go ahead and combine like terms the way they are. And then I'm going to decide to add the 6x to the other side, which would make that an 11x. Subtract the 15 from this negative 7, make that a negative 22, and when I divide, I get x equals negative 2. The next one is very similar. Feel free to pause this and speed up as you go. We will have to distribute the negative in front of the first set of parentheses, which makes that a negative 7x and a positive 4. Same for the next one, just because that's a common error. Then we will combine like terms, negative 2x plus 2 and negative 3x plus 3. So when I add this, I just get an x. When I subtract, I just get a 1. So my answer is x equals 1. The next one here does involve some fractions. That's another thing. It's still linear equations. There's no exponents or anything tricky like that. One way to do this is to simply subtract that 1/2 p to the other side. We would normally have to have a common denominator. So I'm thinking about this as 3/4 p minus 2/4 p. This is 1/4. If I divide by 1/4, that's the same thing as multiplying by 4. So negative 20 is my answer. A different way to look at this when you have fractions with no variables in the denominator is sometimes you can multiply everything by the common denominator to get rid of the fractions. So if I wanted to look at this one, I would say my least common denominator is a 4. So if I take both sides or every term times 4, 4 times 1/2 p is going to end up being a 2p minus 20 equals 3p. Very similar to what we heard before, but this time I would subtract the 2p over. And we would have negative 20 equals p. So that is definitely one possibility that we can look at there. Let's look at this next one. Really not the option as far as multiplying to get rid of these. So you might see this a couple different ways. We could multiply by the common denominator, which is going to be a 2x minus 5 times an x plus 3, which is fine. Okay, and get rid of our fractions. Another option, but this one you just have one ratio set equal to another ratio. It's called a proportion. And so what you've done for years is you've been able to multiply and do cross products. Essentially, that's achieving the same thing that we would have here. If we do cross products, I take the 2 times the x plus 3, right? Same 2 times x plus 3 here. And I take this 2x minus 1 times here. So if you are just going to do cross products, you get the same thing. 2 times x plus 3 is equal to 1 times 2x minus 5. So I have 2x plus 6 equals negative 2x plus 5. I'm going to add 2x to the left side, to both sides. Subtract the 6. I get a 4x equals negative 1. When I divide by 4, I get a negative 1/4. So again, you could just do cross products. You could multiply by the common denominator. Either way definitely works. Okay. Which is evidently what I was going to show in this next one. I could take out a 4 You're going to take out 2. You're going to take out an x. Okay. So what my common denominator is, basically a 4x, x minus 3. And I could not have my answer be a 0 or a 3. Okay. But I can multiply both sides, or every term, by that. What we're going to see happen is my 4 cancels out, my x minus 3 cancels out, and I'm left with the 1 times the x minus the 2 reduces the x minus 3, so 1 times 2 times x, so I'm minus 2x equals, over here the x goes away, the x minus 3 goes away, and we're left with 1 times 4, which is 4. So if negative x is equal to 4, divide by negative 1, x equals a negative 4. Okay. Some people prefer to get common denominators, which definitely is an option. If you wanted to get common denominators, this I'd have to multiply by x over x. Here I'd have to multiply by a 2 over 2. And here I would have to multiply by a 4 over 4. And you would notice, oops, a 2x here. We end up with the same idea. And we say if these are equal ratios and x is equal to negative 4, the denominators are equal, it also follows that the numerators are equal, and you work from there. So, section 1 is all about solving linear equations. We did not have any final values that were exponents. We can restrict our domain and go from there. Lots of options. I want you guys to try these 5 problems, and we'll discuss in class.